Hey guys, today we're going to do our uniform acceleration lab, and we're going to collect some data, distance and time, plot a graph, and show that an object is accelerating. So the general idea here is, for example, let's say we have motion going in just the x direction. So we have a marble rolling in just the x direction. So if it's rolling in the x direction, we're going to say that there is no acceleration. Okay, because it's on this little table. So what would happen to that marble if it were to roll off the table? So if this marble were to end up over here, it would have, in the y direction, it would have gravity accelerating. So what happens is if we take this little marble and we drop it, it's falling so fast, it's very hard to time with just your hand. Okay, so if you had an electronic timer or something like that, it would be better. But so it's gravity, the acceleration is so fast it becomes difficult to time. So what we can do is, instead of it rolling in the x with zero acceleration, falling in the y with this really large acceleration due to gravity, we can put this object on an incline. So if we place our marble on an incline and let it roll down this incline, the incline is going to slow it. It's going to be the answer to the acceleration will be somewhere between gravity and zero. Gravity is 9.8 meters per second squared. So our answer is going to be somewhere between 0 on the x and 9.8 on the y, depending on how much of the slant we have. That's the general idea of what we're doing. So you're going to be watching a video of a wooden ramp. So we have a wooden ramp. On that wooden ramp, we have little pieces of paper, red papers. Those papers are flagging certain distances. So we're going to make a data table, and the data table is provided in a link. You go back and find that data table, or you can make your own. But the data table is going to be distance versus time. Okay, and each of these flags represents the distance in your data table. So the first flag is going to be the first distance, 0.10 meters. So we've already measured that for you. Okay? The second flag, 0.20 meters. And you will just continue. So every time you see a flag, be careful to stay in order, then that flag is the corresponding distance on your data table. So we're going to have a marble at the top of your ramp, and that marble is going to be rolling down the ramp. Now remember, if there were no ramp, it would have 0 acceleration. If we let it fall straight down, it would have an acceleration due to gravity. So our answer is going to be somewhere between those two, but it's still going to be accelerating. What you're going to do is you're going to play the video, and the marble is going to roll, and what you'll do is when the marble rolls, you'll pause it. So when that marble gets to that first flag, you'll pause the video. In the video, there's a computer that has a timer on it. You'll read that time and record it in your data table. When the marble is at the first flag, that's your first distance, you record its time, okay? Then you're going to play the video or move it forward a little bit. When that marble gets to the second flag, that's our second distance, record your time. And you continue that progress, pausing the video at each flag and reading the time. So the video will start to play in just a few seconds, and so you can pause it and record. So this time, collect your data.
Roll it.
Okay, guys, so now you should have a list of data all the way from 0.1 meter all the way down to somewhere around 2.00 meters. So you should have data all the way to 2.00 meters. Okay? Now, so then you have your time filled in as well. So now we have our distance and our time. So what we're going to do next is we're going to make a graph. So we're going to graph the motion using a position versus time graph. So you're going to take your distance data on the y-axis, your time data on the x-axis, and you're going to create a graph of that. So at this time, make your graph. Okay, so you should have made your graph by now, And your graph should look something like this. It should be just a nice little gentle curve. Should not be a straight line. Okay, because remember, on a position versus time graph, a curved line shows that the object is speeding up. We know it's accelerating, what we should be showing in our data. So once you have your graph and it looks like this, now remember you may have a few points that don't exactly line up, but you should have the majority of your points on that line. You may have a few that are off, okay? That's okay. So the majority should connect. You have a nice, gentle, sweeping line. At this time, you should be ready to go back to the lab paper and look at the additional questions about calculating acceleration, calculating the ratio, and the slope. So I want you to go work on the second part of your lab paper at this time.